It's the machine that visits your street every week. A familiar roar, a mechanical arm that devours entire bins and leaves loaded with your most mundane secrets. But behind that daily ritual lies an operation of brute force, dirty engineering, and advanced technology that you never see. What really happens inside that steel monster after it swallows your trash? Today, we're not only going to open it up to see what goes on inside, but we're also going to show you why modern garbage trucks are more fascinating and brutal than you ever imagined. The indestructible classic manual rear loader. This is the original face of garbage collection. The manual rear loader is a living legend, a truck that relies not on circuits but on muscle and human synchronicity. Its design is a confession of simplicity. A cab, a huge rectangular container, and a rear gate that opens like a portal into the monster's interior. There are no robots here. 2 or 3 operators walk alongside the vehicle, grab black bags, drag containers, and with a powerful arched movement, throw the waste into the abyss of the hopper. It's a ballet of pure physical effort. But the magic, or rather the brute force, begins once the trash is inside. At the bottom of that rear opening, hidden from view, lies the heart of this machine, the compactor plate. It is a slab of solid steel, powered by powerful hydraulic cylinders. Its work is methodical and brutal. After every few throws by the workers, the driver activates the system from his cab. The plate emerges from below, sweeping across the entire rear hopper with unstoppable force. It not only pushes the loose trash toward the main body of the truck, it crushes it against the load already inside, compacting it into an increasingly dense mass. It is like a giant piston that, cycle after cycle, builds a wall of waste. Its domain is difficult terrain, neighborhoods with narrow streets, parks where large trucks cannot enter, areas where automation is not cost-effective. It is not the fastest, nor the most technological. But it is the most resilient, the one that can continue to function when more complex systems fail. It is the marine of the garbage service, reliable even in the most disorderly conditions. The robot arm, automatic side loaders. The evolution came with an arm. The automatic side loader is the quantum leap that eliminated the need for a human to physically touch the trash. Here, the truck is a lone predator. It only needs a driver to guide it with pinpoint accuracy along the curb. The star of the show is a mechanical appendage mounted on the right side of the vehicle, a combination of crane, claw, and sensor. Its prey, standardized containers with RFID chips or specific codes. The process is hypnotically efficient. The truck stops next to the container, a system of cameras and sensors identifies and aligns it. Then, the robotic arm extends, its claws close securely around the edges of the bin, lift it cleanly above the truck, tip it over the side chute to empty it completely, and gently return it to its exact position on the ground. All in less than 30 seconds. No spills, no torn bags on the sidewalk. But within this category, there are 2 distinct philosophies separated by an ocean. In the United States, the arm tends to be larger and more powerful, designed to handle the giant 90 or 300-litre wheeled bins that are standard in suburbs and businesses. It is a system of strength for a country of great distances and large volumes. In Europe, especially in cities with streets that are medieval relics, the design is one of compaction and extreme precision. The arms are more agile, the trucks are narrower, and the bins are often smaller and better integrated into the urban landscape. The efficiency of the European system is often greater on dense routes, but the initial cost of the fleet and smart container infrastructure is a huge barrier. This is the ultimate trade-off: extremely high capital costs in exchange for a drastic reduction in labor, impressive collection speed, and a significantly cleaner process. It is automation at the service of urban hygiene. Front loaders and roll-off trucks. When waste is no longer household bags but tons of rubble, old furniture, or commercial waste, the titans enter the scene. The front loader is the undisputed king of shopping center parking lots, industrial parks, and large apartment buildings. Its design is unmistakable. Above the cab, it carries a pair of massive forks like those of a forklift, but on a monstrous scale. The truck does not approach the trash. The trash waits for it in metal containers the size of a small truck. The driver aligns the forks with the container rails, inserts them, and with a gentle hydraulic lift, raises the entire container, which can weigh more than a ton when full, above his own head. He then tips it over a chute behind the cab, emptying its contents in a crash of rubble and plastic. It's a pure demonstration of strength. But there is an even more specialized relative, the roll-off truck. This vehicle completely forgoes compaction. It is essentially a heavy trailer with a powerful winch system and an inclined platform. Its job is to transport open containers, often the size of a small room, used on construction sites, demolitions, or large events. The process is simple and effective. The truck arrives empty, deploys its arms, hooks up the empty container, and drags it onto its own platform. It transports it to the job site, where it is filled with debris. Then it returns, lowers the full container by rolling it off the platform, leaves it on the ground, and takes another empty one. There is no compression, no processing. It is pure logistics, moving colossal volumes of material from point A to point B. These giants do not travel through residential streets. They are the beasts of burden that operate in the backroom of civilization, handling the waste generated by construction and large-scale industry. Double and triple compartment trucks. While some trucks specialize in strength, others specialize in precision and separation. The multi-compartment truck is the physical response to the growing obsession with recycling. It is a single vehicle that does the work of two or three. On the outside, it may look like a conventional side or rear loader. On the inside, it is an engineering maze. A longitudinal steel divider splits the main body into separate watertight chambers. One for organic waste, another for light packaging, plastic cans, cartons, and another for the rest, non-recyclable. Some advanced models in Europe even have a fourth compartment for glass. How does the logistical magic work? It depends on the collection system. In the most advanced model, citizens have different colored containers. The truck's robotic arm, equipped with an optical reader, identifies the color of the container, empties it, and automatically directs the waste to the corresponding chamber using software-controlled internal gates. Each chamber has its own independent compaction system so that cardboard does not mix with food waste. This level of sophistication is more common in European cities such as Berlin, Stockholm, and Barcelona, where separation at source is strict and the infrastructure is mature. In the United States, adoption is more gradual and fragmented, often seen in communities with a strong environmental awareness or in pilot programs in large cities. The challenge is not only technical, but also involves public education and massive investment in containers and fleets. But the benefit is monumental. A single truck trip collects, separates, and pre-compresses 3 different waste streams, saving fuel, time, and cross-contamination. It is the garbage truck designed not to hide filth, but to sort it and give it new life. The compaction mechanism, how it really works. Beyond the loading method, whether it's an arm, a shovel, or operators, almost all of these trucks share a vital internal organ: the compaction system. It's the process that transforms mountains of loose, bulky waste into a dense, manageable block. Think of it as a 3-part mechanical digestive system. First, the hopper. It's the monster's mouth. A reinforced steel cavity, often with sloped walls, where the trash makes its initial entry. Here, everything is chaos. Next comes the compactor, or sweep blade. It's the stomach and muscles. It is a massive steel plate, sometimes with teeth or blunt edges, powered by hydraulic cylinders operating at pressures that would make an excavator pale in comparison. Its movement is not just pushing, it is crushing. After picking up a load in the hopper, this plate advances with a force that can reach 30,000 pounds. It doesn't push the new trash into the air. It pushes it against the already compacted mass in the main body, exerting colossal pressure. Cardboard is turned into sheets, plastic bottles burst and fold, wood splinters, cans bend like aluminum foil. Finally, the main body or container. This is the intestine where the block is formed and stored. Here, layer upon layer of crushed waste accumulates, forming an almost homogeneous solid. Systems vary. Oscillating plate compactors make a sweeping motion and then rise to retract. Sliding panel systems push the waste in a straight, forceful motion. And the most aggressive auger compactors use a huge rotating screw that not only pushes but also crushes and tears the waste as it pushes it into the body. The goal of all of them is the same: to maximize density. A truck that does not compact could carry 2 tons of loose garbage. The same truck, with good compaction, can carry 8, 10, or even 15 tons of the same material, multiplying its efficiency per trip by 5. It is this relentless pressure, this titanic squeeze, that allows a single vehicle to clean hundreds of homes before having to retire. It is brute and intelligent force applied to our most domestic and universal problem. Compaction is only the first act of the drama. Once the trash is crushed in the bowels of the truck, a silent battle begins against corrosive elements, hidden dangers, and military precision logistics. The interior of a modern garbage truck is not a passive container, it is a hostile environment monitored and controlled by technology designed to tame chaos. This is where dirty engineering meets high technology to tackle the most repulsive and dangerous challenges of the trade. From toxic juice that corrodes steel to the possibility of an explosion, this is a journey into the dark side of waste collection. Leachate and the battle against rot. Compacting tons of organic matter, food scraps, diapers, garden trimmings under extreme pressure has an inevitable and disgusting consequence: the creation of leachate. This is not just dirty water. It is a highly corrosive, acidic, and foul-smelling chemical and biological broth. Imagine the juice of 1 million trash cans fermenting under pressure, loaded with bacteria, organic acids, and heavy metals that leach out of small objects. This liquid is the arch-enemy of truck longevity. If it stagnates, it eats away at the steel from the inside in a matter of months, weakens the welds, and produces an odor that permeates everything and haunts the vehicle like a curse. Modern engineering wages a war on several fronts against it. First, the floor design. Truck bodies are not flat. They slope towards central or side drainage channels, often lined with corrosion-resistant stainless steel. These channels direct the leachate to exit points with sealed valves. Second, the linings and seals. Interior walls may have high-performance epoxy coatings or special steel sheets that repel adhesion and corrosion. The joints of all gates and movable panels are sealed with high-density rubber gaskets that prevent liquid from escaping and dripping onto the streets, a problem known as weeping that is a public image nightmare and leads to fines. Third, neutralization. Some advanced fleets, especially in Europe, use automatic spray systems that spray deodorizing and bioenzymatic agents into the cargo chamber. These products not only kill the odor, but also begin to break down organic matter, reducing the acidity of the leachate. The battle against this rot juice is constant and defines the difference between a truck that lasts 5 years and one that lasts 15. Sensors and internal cameras. Decades ago, the driver only knew the truck was full when trash began to overflow from the hopper. Today, the interior of the beast has a digital nervous system. Internal surveillance cameras are now common equipment, especially in recycling and high-end trucks. They are not for spying. They are critical diagnostic and safety tools. A camera pointing at the hopper allows the operator to see from the cab if a bulky object or a misplaced bag is preventing the gate from closing properly or blocking the compactor. But its most crucial function is the detection of hazardous materials. A high-definition camera can alert the operator to the presence of a computer monitor, a swollen lithium battery, a chemical drum, or a fire extinguisher. All items that can cause fires, explosions, or contaminate entire loads of recycling. Alongside the cameras, weight and pressure sensors work tirelessly. Load sensors in the chassis measure the total weight in real time, showing the driver a reading in kilograms or pounds on a display. Even more sophisticated are the hydraulic pressure sensors in the compaction system. When the block of trash in the main body reaches maximum density, the pressure required to continue compacting skyrockets. The sensor detects this spike and sends a light and sound alert. Load full. This precision prevents overloads that damage the equipment and optimizes each trip, ensuring that the truck carries exactly the maximum safe capacity on each trip to the landfill. The truck is no longer a black box, it is a transparent and measurable system. Extreme safety systems. A garbage truck is, in essence, a giant hydraulic press on wheels. And that force, which can shape metal, does not distinguish between an old refrigerator and a human arm. Accidents, although rare, are catastrophic. That's why safety is not a feature, it's a design obsession. The first and clearest line of defense is physical warnings, giant signs reading, danger, no entry, and the iconic pictogram of a silhouette being crushed by a plate engraved on the hopper. But warnings are not enough. Emergency stop, E-stop switches are ubiquitous. There are large red buttons both on the outside of the truck, within reach of a pedestrian or colleague, and inside the hopper for an operator who might become trapped during an inspection. Activating either of these instantly cuts off all hydraulic power, freezing the machine. Perimeter security has also taken a leap forward. 360-degree vision cameras give the driver a synthetic aerial view of their immediate surroundings, eliminating deadly blind spots near the rear wheels and sides. Ultrasonic proximity sensors emit a stepped alert, a soft beep when an obstacle is near, and a continuous shrill sound if the object is about to be hit. In addition, staff training has evolved. Drivers and operators are instructed to perform a quick visual inspection before emptying large containers. They look for signs of danger: the characteristic hiss of a propane gas tank, the metallic sheen of a car battery, the rectangular shape of a tube television. In many fleets, they have the authority to refuse containers suspected of containing hazardous materials. It is a combination of hard technology, sensors, cameras, and soft procedures, training, designed to protect both the public and workers from the unstoppable force they themselves control. Where and how the monster is unloaded. When the sensor announces full load, the truck does not head directly to a distant landfill. That would be a waste of time and fuel. Its destination is a transfer station, the hidden nerve center of the waste system. Here, the truck is weighed on a weighbridge, recording its exact tonnage, key data for billing and statistics. Then, it heads to an unloading dock. This is where the true shape of the load is revealed. The driver activates the hydraulic controls. The large rear door of the truck body unlocks and swings upward. Then, the ejector panel springs into action. This is a steel wall, different from the compactor plate that runs the entire width of the body. It advances slowly, with immense but constant force, pushing the perfectly compacted block of garbage, now the exact rectangular shape of the truck's interior, outward. The garbage does not fall apart. It slides out like a giant brownie of waste, maintaining its cohesion, and falls into a receiving pit or directly into the trailer of a long-distance transport vehicle. These trailers, often without their own compaction, make the economical journey to the final disposal site, which may be hundreds of kilometers away. And what is that final destination? It depends on geography and politics. It could be a controlled landfill, where the block is buried. An incinerator or energy recovery plant, such as the famous ones in Sweden, where waste is burned under controlled conditions to generate electricity and heating for thousands of homes. Or a sorting and recycling plant, where the block is torn apart by machines to recover metals, plastics, and other valuable materials. The collection truck is just the first link, the collector, in a massive and complex logistics chain that decides the final destination of everything we throw away. Electric trucks and AI. The roar of diesel engines and the stench of exhaust fumes are destined to disappear from residential streets. The cutting edge is already electric. 100% electric garbage trucks are operating in cities from New York to Madrid. Their advantages are transformative: zero emissions at the point of use, an almost ghostly silence, only the slight hum of the hydraulic equipment and the electric motor can be heard, and a dramatic reduction in noise pollution, allowing for nighttime collections without disturbing the sleep of neighbors. Range, which was a concern, is no longer such an issue. Collection routes are short and predictable, and trucks can be recharged at the depot overnight. But electrification is only step one. The next horizon is autonomy. Prototypes and pilot tests, mainly in Europe and the United States, are exploring garbage trucks with Level 4 automation. Imagine the scenario. A silent electric truck leaves the depot at dawn. Its LiDAR system, computerized cameras, and radars map the environment in 360 degrees. Artificial intelligence, trained with millions of images, recognizes the city's standard containers, distinguishes their color, organic, plastic, paper, and calculates the exact position for the robotic arm. The truck automatically stops next to each bin, the arm deploys and empties it, internal sensors and CS monitor the compaction, and the vehicle proceeds to the next point, all without a driver at the wheel. A human supervisor could monitor a fleet of these vehicles from a control center. It's the dream of maximum efficiency. A collection service that operates with clockwork precision, reduces labor costs, and integrates seamlessly into the smart city. The garbage truck, once the noisiest and most polluting vehicle in the neighborhood, is destined to become the quietest, cleanest, and smartest. So, the next time that familiar giant rolls past your house, remember what's really inside. It's not just a pile of waste, it's a lesson in applied physics, where 30,000 pounds of pressure turn chaos into order. It's a chemical battlefield where engineering combats corrosive leachate. It's not garbage it's carrying. It's pure engineering, rolling discreetly down your street.